All right, next up is a nitration reaction. So what we're going to do here is we're going to take our benzene ring, add nitric acid in the presence of sulfuric acid, so two strong acids mixed together. And what we'll add is a nitro group, an NO2. So what we want to add is the NO2, which obviously comes from the nitric acid. So you might be asking yourself, what's the point of the sulfuric acid? Well, as we've learned, we need to activate our electrophile. So that's going to be what helps us activate our electrophile. Let's go ahead and take a look at the mechanism of this. We've got our nitric acid. And then we've got our sulfuric acid, which is just going to act as a source of protons. And the alcohol group from the nitro is going to attack the proton from the sulfuric acid. And what that does is it forms a water group right here. As we know, water groups are very good leaving groups. And so what it's going to do is leave. We're going to have this negatively charged oxygen donate its electrons to form a double bond between the nitrogen and the oxygen. And then the good leaving group is going to leave. And then we're going to have a nitrogen doubly bound to two oxygens, right? And you can see how that nitrogen in the middle would be very electrophilic. This is called a nitronium ion. And acts as our activated electrophile. Now that we've got the activated electrophile, the rest of the mechanism is the same as what we've previously seen. Our aromatic ring, which is our nucleophile, is going to attack the electrophile. We're going to break a nitrogen-oxygen bond. That way we don't break the octet rule for nitrogen because we know we're not allowed to do that. This will then result in a sigma complex. And our sigma complex is then deprotonated. Again, usually drawn with water because anytime you have sulfuric acid, you're going to have at least some water. And we regenerate our aromatic system. And then again, this right here is your nitro group. And you can draw it all out, or you can abbreviate it as just NO2. The cool thing about nitro groups is that we can reduce them. So we can take a nitro group and reduce it down to an amine. So you see it goes from NO2 to NH3, right? This right here is an amine. And a benzene ring with an amine is known as aniline. And that'll be synthetically useful later on. To achieve this, what we need to do is just add some iron in the presence of some acid. And then after that, just add a base to work it up. In this case, we won't take a look at this mechanism. It's too complex and it's not really very common. But we do want to know the reaction, and we'll see why later when we get to the synthesis part.